Okay, today we are doing exponential and logarithmic equations, and you have done exponential. You have solved exponential equations already, correct?
Yes.
And so we're going to be reviewing that, and the book is like, ooh, it's brand new. And it's not. I did print these bigger today, so tell me if they're better.
That's a lot better.
Okay, so the top one, be careful what you're writing. You don't need to write everything. Okay, the top one is the equality property for exponential functions. So if b to the x equals b to the y, what has to be true? X equals y. If the bases are equal, the exponents are equal, right?
Yeah.
Okay, so with logarithms, guess what? If the bases are equal, the ofs are equal, basically. Okay, so log base b of x equals log base b of y, so x has to equal what? Y. So with exponential, we could get rid of the base and just solve the exponents, right? With logarithms, we can get rid of the log and the base and just take the ofs and set them equal to each other and go. So it's a really nice property to have and to be able to use.
So we're just supposed to write what you highlighted?
Yes, that's what I would name it. Exponential, it's property of equality for exponential equations, and then property of equality for logarithmic.
Let's say log b of x equals
Log
b of y.
base b of x equals log base b of y. Oh, I need to get a yellow highlighter, huh? Sorry.
Or a pink one.
That is pink.
Oh,
That's why I was confused.
What's purple?
Is that a little better?
Orange.
Okay, can we stop? Being rude. I'll just underline next time if I need to do it again. Okay, ready? Well, you're not writing very much.
I just kept writing it wrong. I'm trying to redo it.
So just to review the first couple, I have 1/2 to the x plus 7 equals 4 to the 3x. So I need to get the same bases, right? What's the same base we're going to use? 1/2 and 4. What can we get them both to? 2. So the 1/2 we can bring it up and make it a -1, right? So I have 2 to the -1 to the x plus 7 equals, what about 4? Is 2 what? Squared. So 2 squared to the 3x. Now, only thing really different this time is we probably have to do what with that -1? Distribute it. So that's about the only thing different this time, right? And I think we did a few of those last time. So this would be what? Because it's x plus 7 here. Okay. So this would be, the bases are equal, so I can just set the exponents equal, right? I have -x minus 7 equals 6x. Then I have a basic algebra problem, right? What do I do next? Add the x. So -7 equals 7x. So x equals -1. You good? Okay. This is wrong. Don't write that next one. I didn't catch it. I forgot to. It should be 25 to the 3x equals 125 to the x plus 2.
So if we just go down with
5, right?
wouldn't it be 5 squared
So 5 squared
and 5 cubed?
to the 3x and 5 cubed to the x plus 2. Well, now, why do I keep putting parentheses around that x plus 2?
Because it's on
It's all one thing. And I got to make sure I do what with that 3? So I got 6x equals,
3x plus
no, you
2.
didn't.
3x plus 6.
Thank you. 3x plus 6. Then what am I going to do?
Subtract 6 and then
And so x equals
2.
Okay, so we've done ones like that, right?
Yeah.
Okay, so we're going to mix them around and do some different things with them. Just have,
Don't say it's 6.
Yeah, I was just about to say, have fun.
you good? Okay. Well, what if they don't equal?
Then it's no solution.
No.
No, you don't. You do it the other way.
We do what other way? What have we been doing? Logarithmic form, right? So, log base 4 of 17 equals x. Log 17 log 4. And what base did we just turn it into? 10? We used the change of base formula. Well, yes.
Forgot your parentheses.
These ones? Okay, I also can do what? I don't have to do base 10. I could do base
Oh,
e. So natural log of 17 over natural log of 4. And that gives you 2.04. And make sure you put approximately because it's an approximate. Yes? I'm going to change this one right here.
No.
No, just that x. I'm going to make it 2x. Okay? So I just put it 2x instead of x. So I have 5 to the 2x equals 12.
Log 5.
Log base 5 of 12 equals 2x. So then I would, yes, divide by 2. But I need to do change of base formula, right? So I would have x equals log of 12 divided by log of 5, and then divided by 2 or multiplied by a half. But I don't want to write it like that. That looks really bad, right? So could I write it log of 12 over 2 log of 5? Yeah? Because I just multiplied the top by 1 and the bottom by 2, right? Okay, so sometimes you'll have things like that. And again, I could do natural log as well. Yes? So the natural log of 12 over 2 natural log of 5. I know our pre-calculus book does natural log all the time. And I tend not to use natural log unless I have an e involved, but it doesn't matter. It's what? So 0.38, so approximately 0.38. Okay.
The natural log ones on the homework
Mhm.
kind of confused me because I didn't know if the other base one was.
What's the base on natural log? E.
But like,
There is one of them that had to be like log of something over log of ln.
ln of e.
Yeah, there's.
But what is ln of e?
2.1?
No,
One.
it's just 1. the natural, if you ever get the natural log of e, because what's the base? E, so it's just 1. So if you had something over the natural log of e, then it should have been just itself. Did we have any questions on homework? I didn't ask. Did we have any?
I don't think there was an equation like that.
Oh, okay.
I never had an equation that way.
Okay, so now I've got 3 to the x plus 1 equals 5x. Now, a little bit different because the problems I just gave you only had 1 x, like it had 1, correct? Yeah, and I could just take and change it that form. But in this one, I'd have like a log base 5 and a log base 3. That wouldn't work very well, will it? Would it? Okay, so I need to get these out of the exponents. Do I have a property of logarithms that can do that? The power property, yeah. And I know if I want to do, can I do anything I want to an equation? Yeah. As long as I do it to what? Both sides. So if I know I have a property of logarithms that I can get those exponents out of the exponent, I can insert a log here and here. So I can do the log of 3 to the x plus 1 equals log of 5 to the x. What base did I put that in also? 10. I did it to both sides, right? That's legal. So now what can I do with my exponents? No. No.
Put them in front.
Put them in front. So I have x plus 1 log of 3 equals x log of 5. Okay, so we got them out of the exponent. We're good there. But I've got to get into that quantity, and I can't get into that quantity until I do the multiplication, correct?
Yeah.
Evan, you're not even paying attention. We're not using a calculator. Okay, so what do I need to do with this log of 3? I need to distribute it. I can't get that x out of there until I take care of the multiplication, can I? So it's going to be x log of 3, because log of 3 is a function. I'm not going into the function. Plus 1 times log of 3, which would just be log of 3 equals x log of 5. Okay, so like any other equation, when we got x's on both sides, we got to get them on one side, correct? So I'm going to subtract x log of 3 from both sides. Now, I want to be very specific about this, and I want everyone to listen to me. Log is a function, yes? This is log of 5, and this is log of 3. Are they the same things? No. You cannot subtract them unless you had them in decimal form. Got me? If it was 2x log of 5 minus x log of 5, then could I subtract it and just get x log of 5? Yeah. But these are not like terms. We can't do it. Got me? Okay, so I have log, this is zeroed out, so I have log of 3 here. But my problem over here is I have 2 x's, yes? But I have one term and I have another term, and what do they have in common? They have an x.
I said x.
Can I factor it out? Yeah. I distributed this in, didn't I? So can I factor out the x? And then I would go from 2 x's to just what? 1. And then I can solve for it, can't I? So I have x times the quantity log of 5 minus log of 3. And like I said, I always say it's a basic algebra problem. It's an algebra problem with a really long unknown, right? But it is just an algebra problem. We've done that with x's before. Now what? Solving for x, right? I got it. No, not set it equal to 0. I don't have a quadratic. You were right. I have to divide by this whole thing, don't I? So I have x equals log of 3 divided by log of 5 minus log of 3. Now, you notice I put parentheses around the bottom. First of all, to remind myself that I can't reduce these things, can I?
Yeah, I was about to say that.
Yeah, I can't because of the subtraction. Also to remind myself when I put them in my calculator, what do I have to make sure I do? Put the parentheses. Okay, when I put that in my calculator, it is approximately, and the top one is the right answer. I want to show you without the parentheses. So when I put it, I have log of 3 divided by parenthesis log of 5 minus log of 3. It's approximately 2.15. That's the answer. Look what happens if I don't put the parentheses. Do I get the right answer? No, because your calculator took log of 3 divided by log of 5, then subtracted the log of 3 from it. And that's not what I wanted to do, is it? Bad. No, no.
So you should get 2 points.
1.5. Oh, yes. So let's go through what we did and why we did it. Okay. So at the beginning, why couldn't we do the same thing with the problems before? Why couldn't we do the same thing? Because we had an x on both sides, right? In both. So we took the log of both sides. And that's legal, right? And we did that because we knew we could get our exponents out in front of the logarithm when we were done with it, couldn't we? We'd use that power property. So we did that. Why did we have to distribute the log of 3 in here?
To be able to get it, to get it out of the...
To get the x out of the quantity. And then we moved all the x's to one side. We had 2 x's, I need 1. So I factored the x out and then just divided. Have we done that pattern before with other things? Yeah. Now you just have a log of 5. And some books will calculate that out and then take this 4 decimal 4 digits and move it around all over the place. Would that be hard to I'd mess it up. I would mess it up. Isn't it easier just to take the log of 5, log of 3, and just kind of move it around? Yep. Okay, so I've got 2 to the 3x equals 7 to the x plus 1.
How long?
We're going to log, but we're not going to do base 10 this time. We're going to do natural log this time, just to show you that you can do it both. So we're going to insert that natural log. I had a class one time that we're going to log it up. So 2 to the 3x, or the natural log of 2 to the 3x, and the natural log of 7 to the x plus 1. And since we did that, we can use what property?
The power property.
The power property to give me 3x natural log of 2 equals x plus 1, make sure that's in parentheses, natural log of 7. You have to have that in parentheses. That's the whole exponent, right? And if I forget my parentheses, I'll forget all of that. Evan, are you paying attention? Okay. Is my left side good?
The left side is...
I don't think you understand that I can physically not make a wavy
Can
L.
you move? Can you move that one?
Well, is the left, okay, the left is one thing, yes? There's no addition subtraction, so is it good?
Yeah.
Yes. So I'm fine. But I need to be able to get to that x, and I can't get to the x until I take care of the quantities, so I have to distribute the extra log. So 3x natural log of 2 equals x natural log of 7 plus, what, just natural log of 7, right?
Why are there two natural logs of 7?
Because you distributed the natural log of 7. You have x natural log of 7 and 1 times natural log of 7.
So you should be 7, so would that be a 7? Would that be a 7 natural log of 7?
If you have
Mm-mm.
another one like that too.
You don't distribute a 7, you distribute the natural log of 7. You're
Oh.
distributing the whole thing.
Well, the last one you had the arrow 7.
Well,
It looked
okay.
like maybe your arrow 7 was a 3.
Here?
I don't know. It looked like
Okay. So now what?
So X is to one side.
Okay, x is to one side, so are we gonna go left?
Yeah.
Two on
Left,
that,
two,
two on that.
Okay, I had it in my head too. Okay, so 3x natural log of 2 minus x natural log of 7, right? Equals natural log of 7. At least you only have 2 letters to write if you do natural log, right? Okay, so all my x's are on one side, but I still, not divide, well, kind of, but factor. I gotta factor first, don't I? And I'm only factoring out the x. The 3 is going to stay there, right? So x, and what am I left with?
3 natural log of 2
3 natural log of 2,
minus natural log of 7
natural log of 7.
equals natural log of 7.
Now
Now you divide,
I can divide by that big old chunk of stuff, right?
and then that equals the X equals
So x
natural log
equals
of 7 over
3 natural log of 2 minus natural log of 7. So did we do the same steps just with natural log this time?
We got the final answer.
Well, then you can put it in your calculator.
Like on the test if you didn't have a
Yeah, if you didn't have a calculator, that would be your final answer. If you put it in your calculator correctly, you should have approximately 14.57.
14.
Yep. Seems large.
Yeah.
Mm.
You can buy your own.
Mm-hmm. But if you think about it, you've got to get 2 to a power to equal 7 to a power. So it'd probably get pretty high before they actually equaled out, right? Yeah. You probably have to go quite a ways before you found a common
Maybe you should do it
multiple.
eventually without actual math.
I'll do this all day.
So we understand
Mm-hmm.
what's going
Yeah, that's called a waste of time. That one.
on.
That's not really that bad.
Okay. Natural log of x squared minus 16 equals natural log of 16. Wait. What do you notice?
There's negative in the parentheses.
What are the bases?
It's already
Basis
set up.
of
No.
What's it say?
10.
X equals y. It's the equality property, right? Because what's my base? What's my base on both of these?
10.
Well, E.
E.
That's
It's base E on both, yes? So if the bases are equal, the obs are equal. So x squared minus 16 equals 6x.
So now, we can move that to one side. Take that out.
Now wait a second, it's a quadratic. What do you have to do when it's a quadratic? Good one. Good
Can
one.
you take square root of it?
No. Not yet.
Subtract the 6 over.
It has to be equal to 0.
Oh, yeah.
Then we have to factor
Oh,
So, because it's quadratic. So x squared minus 6x minus 16.
And then now you factor it.
Now we factor.
it'll be
Negative 8 and 2. I'm so glad I heard answers without me having to spell out how to do it. That's amazing. You
I still got to do
so.
What?
I still got messed up on factoring.
Okay.
I just suck at factoring.
1 times 16 is 16. Factors of 16 that have a difference of 6. Negative 8 and 2.
Okay.
And it's a 1, so I don't have to do the whole other process, right?
You don't have to do
my
the
factoring
factoring.
sucks no matter what. No matter how many times I'll practice it.
Well, it's just we're just gonna keep working on it for you there, Ethan. So x equals what?
X equals 8, negative 2, and 8.
Okay, so x equals negative 2 and 8. Now, we've talked about extraneous solutions, meaning extra, like they sometimes don't work, right?
Plug it in and see if it works.
When we have something that has a limited domain, like logarithms, do we need to think about that?
I don't think negative 2 will work.
Okay, the domain is what for a logarithm?
The mean of all that.
No, it is not.
No, it's
Oh, wait.
what zero.
X is greater than 0.
X is greater than 0, yes?
Range
Mm-hmm.
Range
Now,
is
range is all real numbers, that is correct. Now, we are plugging these into equations, so we have to just do the math and check. We can have a negative number as long as when we're done, we don't come up with a negative number. Get it? Okay, so negative 2 is 4 minus 16, that's negative. Is it going to work? No.
No.
It also makes the other, and I wish they would have only made one of them not work. It doesn't, it's usually only like one thing. If it makes one thing not work, it doesn't work for anything. It doesn't have to be both. Is that clear on everybody? Because negative 2 makes both of them negatives, and I wish it would have made one a positive and one a negative to show you that. As soon as it makes something wrong, the whole thing doesn't work.
Then it makes both of them negative.
So, negative 2, I'm not going to scribble it out. I'm just going to draw a line through it, right?
64.
So does 8 work? 64, that's going to be positive, and that's going to be positive, so 8 is good. So x equals 8.
They don't have to be matching numbers as long as they're positive.
Yep. Because you don't know what this is. Like you don't know the natural log of 48. You need a calculator for that. If I were to graph these, they would meet where? When x is what? No, when x is what? 8. So at x is 8, these two graphs, maybe what they would, oh, I didn't, here, we'll put this as 8. These two graphs intersect. That's what's happening there, right? So we know at 8, when x is 8, but I don't know what the outcome is. I could put it in my calculator and see.
Natural log of 48.
No.
Natural log of 48 is 3.87.
3.87. So this right here is 3.87.
So even if the negative 2 worked on one of them, it's still wrong.
Yeah, as long as it makes one of, let's say if this was like 16 minus x squared, okay? So 16 minus x squared, the 2 would be fine here, but would it be fine here? No. The 8, would it be fine here? No. And there, and so if it's none of them make it right, it's what? No solution. Okay? So there could be one of them right, there could be both of them right, or they could be
All right.
All wrong.
all right, all wrong, none wrong. Okay, another one.
Or it could be
Well, anything is
Log base 5 and log base 5.
That means we can just do
The ofs.
the parentheses.
The ofs.
together.
The ofs are equal. So I just can put the domains equal, right?
That's what I meant.
Yeah, I know. So x squared minus 45 equals
Four.
4x. Now, I only have to set them equal because it is a quadratic, correct? If it wasn't a quadratic, I could just solve it. Well, unless they gave you cubic, but we haven't done much with cubics. So, what's it going to turn out to be?
Seven.
X minus
X squared
9
minus 4.
Negative 9 and 5.
x plus 5.
Yes.
Negative 9 and 5.
And Ethan says negative 9 and positive 5. Is he right?
Yes.
Yes, I am.
So x equals negative 5 and 9.
And they did it again. One of them works and one of them makes both of them wrong.
5 don't work.
5 don't work. 5 doesn't work.
We're so smart.
5 no work.
No 5, no work.
9 does.
I like these ones.
You like these
Yeah, I
ones?
don't like the drawing.
Yeah, the other one.
Other ones weren't too bad.
There's too much work.
My brain
There's
was
too
a
much
little-
work.
They are the same, so we can just put it straight in.
Okay, so try this one on your own.
Okay.
No,
Why? This one, what makes it
This
even
one's
hard?
easier.
It's not hard. You have to think about your factoring a little bit more. Can I start?
Why would it be 1? I thought it would be 2. I thought it would be 2.
What would be 2?
Instead of 2x plus 1, it would be 2x plus 2.
Well, this has to equal 1 when you multiply it.
Oh, yeah.
So how do you know when to do the 2x?
I'll use it, yes.
Okay, so remember when we factor,
I can't remember what exactly.
this is the factors of A and this is the factors of C, yes? Okay, so, and then when I multiply this times this and this times this, I've got to get B, don't I? Okay, and so I take this times this, I get 4. The factors of 4 that add to 4 are 2 and 2. Well, factors of 1 are 1 and 1. So I don't have any choice, do I?
No.
This tells me everything's going to be positive, right? And so this has to be a 2x and a 2x. Or you could do your grouping and do 2x plus 1, 2x, 2x plus 1, and 2x plus 1. See that? Anybody do this way?
I forgot about that.
Who did? Autumn, you did grouping? Okay, so you could do grouping or you could just do them. Okay, so -1/2. Now, it's a negative, and I really wanted to do this one to show you not every negative, since the last 2 were negative and they didn't work, not every negative doesn't work, right? When I put it in here, a negative times a negative gives me a positive 2, so this is still positive, so it works here. And then a negative squared would be a positive, so it would be positive, so it works. And so if this one didn't work, it'd be a no solution, wouldn't it?
Yes.
Okay.
Yes.
Okay, we're not gonna graph them. I did change the assignment from what was online and from what was on the board. I had to 40 online and I had to 30 on the board, and I compromised at 33. The ones after 33 we will look at tomorrow in class. You have to condense, or I could show you and you could try them just to 37. All it goes to.
Nope.
Okay, so tomorrow we'll have to condense before we solve. So if you want to look to 37, just know that you need to condense before you solve. But other than that, we're done for today, so get started on your stuff.